Hey guys.
Hey, Professor, how are you?
Good. How are you?
Pretty okay. Oh, Professor,
Mm-hmm.
can I
What's
ask you
up?
a fluids question?
Sure.
So I'm taking another fluids design class after taking your fluids class,
Mm-hmm.
but I don't think in your class did you ever teach us the term four nominal schedule 40 pipe?
No, I don't even know what that means.
Oh, okay. Yeah.
I mean, it's probably you're probably taking fluid machinery class. That's what it sounds like.
Uh, Machinery. We're just designing a piping system.
Okay, okay. Yeah, a lot of the details for piping is those I don't have I know kind of the basics behind it, but like specific kind of parts and specific knowledge, I'm not that knowledgeable
Oh,
on that
okay.
stuff.
Yeah. It's because I'm a little confused on what it even means.
Hmm.
Yeah.
All right, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everyone. How's everyone doing today?
Hello, Professor. I'm good. How are you?
Good, good. I'm doing good. Thanks for asking. All right, and so this week we're going to start something new, and so we're going to be doing our next set of lecture notes on annual cash flow analysis. Okay, and so now that we've done present worth analysis, you'll see that this annual cash flow analysis is not that big a jump. It's just that instead of converting everything to a P, instead we're going to convert everything to an A instead. Okay. So hopefully this week will be relatively not too bad. And according to my schedule for the class, this is the last topic that we're going to cover. That's going to be on the midterm. Okay. So I think the midterm is scheduled for the beginning or the end of week 6. So I think it's about 2 weeks from now. Let me just double check the date on that. Okay, so the midterm is scheduled for the end of week 6, so it's going to be Thursday, September 30th, and this is the last topic that I have planned for that midterm. Okay, and so we'll talk more about the midterm starting next week, but then usually what I like to do for my midterms is I like to give you guys a study guide to tell you exactly what you need to study to be ready for the exam, and I also like to do a review session to kind of help you study as well. Yeah. Yes. And so the review session, so I've been doing this the last couple semesters just because of the virtual stuff, and I really like it just because it helps me kind of keep more class time. But I've been doing the review sessions kind of asynchronously, right? And so what I like to do is I kind of record the review sessions kind of just outside of class time, and I just post it on YouTube for you guys to look at. Okay. I do let you guys vote, and so just because the review sessions usually span about 1 hour 75 minutes, and that's not enough time to cover absolutely everything, and so I usually let you guys vote on what topics that you want to see most in the review session, and I post the review session on that. Okay, but we'll talk about that more next week. But but just to kind of give you a heads up that the midterms on the horizon already. It kind of feels like we just started, but midterms already coming up. But that's how every semester is. I feel like. Okay. So before we get started, I do want to answer a couple questions on the homework, just because I know this homework that I just posted is a little bit challenging, and so I got a few questions over the weekend, and I want to cover a couple, or at least one that I was that I got quite a bit over the weekend, just so we're all on the same page on that. Okay. And also, if you haven't already, try downloading an updated version of the PDF, because I did make a couple mistakes in my solutions for the problems, most notably on problem 2. So in problem 2, I made a couple mistakes on 2, I think it was 2B and also 2C that I didn't, that I needed to update. So make sure you download the updated versions for that. Okay. Okay. And so my plan for today is I know a lot of people are struggling with problem 3, because that one has the non-uniform cash flows. And so I do want to go over 3B before we get started today. But besides 3B on the homework, are there any other questions I can answer?
2C.
2C. Okay. 2C. Okay, yes, yeah, 2C is the other confused. Actually, yeah, 2C is a good one too. So let me, I'll show you how I set up 2C, and then we'll set up 3B as well. Okay, and then I think those are kind of the 2 most challenging ones on the homework. All right, any other questions besides those ones? Okay, all right. So let's start with 2C, and so we'll go kind of chronologically from the homework assignment. Okay. So this is homework 2. Problem 2C. Okay. All right. And so, a little bit of background on this problem. So this is a problem I've given before on this homework assignment, but it's always kind of been a little bit on the easy side, and also just in the interest of just changing things up every year. I like to change kind of I like to kind of mix around my problems, every single year. So this is a problem that used to be a lot easier, and then I kind of try to change it to make it a bit more challenging, but I think I made the wording a little bit too confusing. And so, this is the other question I got a lot of questions on over the weekend. Right? Okay, and so in problem 2C, the problem reads that the town, city, some town, their city council would like to have a major tunnel be rebuilt and strengthened for its citizens. Okay. All right, and so an engineer, they basically did the did an inspection of the tunnel and basically determined that the maintenance cost will for the tunnel will cost a certain amount of money at the end of the first year. Okay. Okay. I think this is kind of the most confusing part of the problem, and I did try, you know, kind of hard here to kind of make it a little bit more clear, but I think it's still a little bit confusing, right? And so the way to kind of read this part of the problem is that, you know, first of all, you can see that, you know, that what we're trying to compute here is maintenance costs, okay? Right. And that maintenance cost will have a certain value at the end of the first year, okay? And so what these two pieces of information are telling me is that, you know, we need to compute some unknown uniform series. Okay. In other words, we have some unknown A value, okay, that we need to compute. Okay. All right. So what else does the problem say? Okay. And so the problem also says that these costs will decrease by $6,500 each year after the first year. Okay. Okay. All right. And so, you know, the key parts of this part of the phrasing is that, you know, the costs are going to decrease by a certain amount each year. Okay. And so what that tells me is that we have some kind of arithmetic gradient going on, because arithmetic gradient is the only cash flow that we have that's able to change every single year. Okay. And so, you know, here we actually are given the value for this G. Okay. And so this tells us that this G value, we're going to have a G value of positive 6,500. Okay. Right. Because what this is telling us that the costs are decreasing. And so if we consider this cost, this unknown cost here to be a negative cash flow because it's a cost, then to represent that cost decreasing, we can add to that a positive gradient of 6,500. Okay. Right. All right. So the next thing that we have is a one-time maintenance cost of $80,000 at the end of year 3. And so this is pretty straightforward. And so this tells us is that what this tells us is that, you know, we're going to have some future value of $80,000 at the end of year 3. Okay. Right. And then the other thing that the problem tells you is that in order to pay for this, the city has set aside $375,000 today. Okay. Okay. And so what this tells us is that we have a present sum of $375,000, and this is a positive $375,000 because this is money that the city is setting aside to actually pay for all this. Okay. Okay. All right. And so those are all the cash flows in the problem. Right. The other piece of information that you need is you need to know the interest rate. And so the interest rate is given to you in the problem is 3%. And the N, or the number of periods, is going to be 7. Okay. All right. And so the way that you can solve this problem is you can set up a present worth calculation. Okay. And so you basically convert all 4 of these cash flows into a present sum. Okay. You're going to add them all together with the appropriate signs. And so for all the costs, you're going to give it a negative sign. And for all the benefits or all the cost decreases, you're going to give that a positive sign. Okay. Convert everything to a present worth. Set it equal to 0. Okay. And then what you're going to have from there is an algebraic equation that you can solve for A. Okay. Okay. Right. And so, you know, I'll give you kind of a preview of what that looks like. I don't want to set up the whole thing, because then that's basically the whole problem for you. But you know, but you know, kind of the point of this kind of walkthrough right here is, you know, when you have kind of a big kind of lengthy word problem like this, it always helps to kind of break down the word problem kind of step by step. Okay, because what you're looking for in these economic problems is, you know, what are the cash flows that I'm going to be working with, and how do I actually, you know, work with them. Okay, a lot of times, you know, these you know, these problems are going to boil down to like a simple algebra problem, and so you're going to solve for something that's unknown. Okay. And so, you know, it's, you know, kind of the tricky thing to setting up these problems is, you know, how do I get the algebra problem from this kind of word problem right here, okay? And so kind of a hidden kind of, I think, difficulty to these economics problems is that, you know, they're all going to be, you know, word problems to some degree, right? And so I'm going to give you like basically an economic situation or an engineering situation, and you're going to have to kind of tease apart, you know, what are the numbers here and how do I fit them into, you know, my formulas or the compound interest table, okay? And it can be difficult, especially when there's a lot going on in the word problem. So, you know, taking it kind of sentence by sentence and kind of, you know, line by line, I think helps a lot with these kinds of problems. Okay. All right. Any questions on any of this so far? Okay. And so the way I would set up this equation for this is I would say that, you know, the present worth for this entire problem will be equal to, you know, let's start with the A, right? So the unknown A is going to be negative A, okay? And then we're going to have to convert that to a present sum, okay? So we have to multiply that by a P over A factor, okay? Plus a G, okay? And to convert that to a present sum, we need a P over G minus F, which is a P over F, okay? Plus P, okay? Right? And notice how I picked the signs. I picked the signs very carefully. You know, this is not a general formula here. So the positive and negatives that I chose for this are specific to this problem, right? And so that uniform series that we had, that represents a cost. And so that's why I put a negative there. Same thing with the future sum. The future sum is a cost. And so that's why I put a negative. Meanwhile, the G and the P are either, you know, present sums or, you know, a benefit, or they represent the amount that the cost is decreasing. So that's going to also be a positive. And then we can set all that equal to 0, okay? And then what we can do from here is that, you know, all of these parentheses values you can look up in the compound interest table, and then you'll have a simple algebraic equation that you can solve for A, okay? All right, and so this kind of technique where you kind of take all the cash flows, you convert it into a single form, and you add it, and you set it equal to 0. This is what's called balancing the cash flows, okay? Okay, and so this is a technique that you'll use a lot in this class, just because, you know, a lot of times when you're given a situation which has several benefits and several costs, right? A lot of times you'll be solving for something such that all the cash flows kind of balance each other out. Okay, and so, you know, that's what this kind of means, and that's how you set up this problem. Okay. All right. Any questions on this? Does it help make it a bit more sense, that problem? Okay. Okay. And so let's do problem 3B real quick, just to kind of show you how that one's set up, because this is another one where there's kind of a lot going on in the word problem, where you kind of need to kind of take it apart kind of step by step. Okay. Okay, and so in this problem, you know, the situation I've given you is that, you know, a baby girl was just born, and then her parents want to save money for college expenses, you know, much longer in the future. Okay, all right, and so once again, you know, we're going to take this word problem apart, kind of sentence by sentence, and categorize the cash flows, and then, you know, and then perform any conversions that we need to, okay? Keeping in mind that, you know, the title for this whole problem is non-standard cash flows. And so, for several of these, you might have to perform more than one conversion, okay? Okay, and so the first cash flow that the problem tells you is that the girl's grandparents gave an initial investment of $3,000 the moment she was born, right? So the moment she popped out of her mom's, baby making organ, her parents like, here's a check for $3,000 and, we'll put this towards her college fund, okay? Okay. And so this $3,000 right here is a present sum. Right. And so the situation you can kind of imagine in your mind is, baby daughter just popped out and dad is, trying to balance his checkbooks right in the operating room. Okay. So he's trying to plan for her future right there. He has Excel open and everything like that. Okay. Okay. And so that's the present sum. Okay. And so the next thing that the problem tells you is that, tuition costs are going to be $21,500 each year in the 18th, 19th, 20th, and 21st years of the girl's life. Okay. 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 All right. And so here we have a uniform series, right? Because it's a cost that occurs, every single year over a period of time. Okay. But this occurs, near the tail end of the cash flow diagram. Okay. All right. And so in order to, let's just say for now, just because that's the only thing we've learned so far, we're going to convert this $21,500 to a present sum. Okay. All right. And so, this is basically so that, you can basically directly compare it to that $3,000 that was given by grandma and grandpa. Okay. All right. But because, this uniform series occurs over kind of a non-standard period, right? And so it doesn't start until year 18, you're going to need to perform multiple conversions on this. Okay. And you only need to perform two conversions. Okay? Okay. All right. And so the next thing the problem tells you is that, in addition to the $3,000 that grandma and grandpa gave, the parents are also able to start investing $2,000 a year, starting in year 6. Okay. Right. And so again, this is going to be a non-standard uniform series because it doesn't start on year 1, so it starts on year 6. And so you need to convert this to a present sum using 2 conversions. Okay. All right, and then the last cash flow you have to account for in this problem is that is some kind of gradient. Okay, because what the problem tells you is that after year 8, the parents are going to be able to increase their contributions amount by a flat amount each year, starting in year 9. Okay. And so basically starting year 9, they're going to contribute, a little bit more each year. Okay. And so I already gave you the answer. And so the answer is going to be, about $103, right? And so starting in year 9, they're going to contribute $2,103. Year 10, they're going to contribute $2,206, and so on and so forth. Okay. But what I want you guys to do is I want you guys to solve for G, using this situation. Okay. And again, this is a situation where you have a gradient, but it doesn't start at the standard time. It starts somewhere really much later. And so again, you're going to have to convert this to a P using 2 conversions. Okay. And then once you've basically done all that, you've converted each of these cash flows into P. You're going to set it up exactly like we've set up here at the top of the screen. Okay, and so you're going to basically add them all together, set them equal to 0, and then use that to solve for the unknown. And the unknown here is going to be your G, which is the arithmetic gradient. Okay. Okay. All right, and so hopefully that helps you guys out with those two problems. So I think those are the two most tricky ones on this homework. Okay. Question. So is it okay to go over an example converting a present sum to using two conversions? Yeah, sure, we can do that. Let me do this 21,500 here. Okay, so let me do that on the next page just to show that. But besides that, are there any questions on this?
Yeah, I got a question. You said 2,000 a year starting at year 6. I'm looking at the file you have on Canvas. It says $2,000 a year for 6 years, starting on the 3rd year of her life. I don't know if maybe I have the wrong PDF.
Oh, yeah. I'm sorry about that. Yeah, you're right. It starts on year 3.
All right, that's all I wanted clarification for.
Thanks. Yeah. No, yeah. Thanks for checking that. Yeah, it's that definitely says that. I think I saw 6 and I thought it said started at 6 years, and so this would be starting on year 3. Yes. Thank you. Okay. Any other questions on this before I do that example on the next page? Okay. All right. And so, we have this $21,500 and it's occurring in years 18, 19, and 20. Okay. And so let me go ahead and draw a cash flow diagram. Okay. And for these homework assignments, I know for the first homework it wasn't really that necessary, but for these problems it can really help you guys to draw the cash flow diagram because that gives you a really good visual way to see all the different things that are going on. Okay. And I know it's a hassle. I know it's not the simplest thing to draw, and it kind of takes a lot of time. A lot of times I'm too lazy to kind of draw it too. But it really does help, especially for these really complicated problems, just so that you can see everything that's going on. Okay, and so even if I don't ask for it explicitly in the problems, it's always a good idea for you to draw a cash flow diagram, just so that you can visualize everything. Okay, and so we're going to do an example here where we have this uniform series, okay, and each of these are going to be 21,500. Okay. And then we want to convert this back into the present day. Okay. And what I told you was that, in order to do this, you need to perform 2 conversions. Okay. Okay. And so the first thing we want to do is whenever you have kind of a like a recurring type of cash flow, so you either have a uniform series or an arithmetic gradient, it's always a good idea to convert this into a single lump sum. Okay. All right, and so let's take this $21,500 uniform series and let's convert it to a single lump sum, okay? Because then from there it's going to be a lot easier to work with. Okay, and so let's take this 21,500, okay, and let's convert it to a single lump sum at the beginning of this of when it started, okay. And so the conversion factor for that is going to be P over A, okay. 3% is the interest rate. And then for the N, you have to count how many years that the uniform series is taking place, right? And so this uniform series is taking place for 4 years. And so we're going to do this for 4, okay? And then, I don't have the compound interest table in front of me, so you can plug in for that value, okay? But basically what this is going to do is that it's whatever the result is here for here, this is going to be one lump sum that represents that uniform series, okay? The question is, where do you put this lump sum, or where does it actually occur? Okay. And so I kind of gave you a hint because I drew in kind of an extra time point there when while I was talking. Okay. And so when you convert a uniform series to a present sum, then that arrow or that cash flow goes on the year before the uniform series starts. Okay. And so for this case, our uniform series basically starts on year 18. And so, when we convert this to a present sum, this present sum is going to take place on year 17. Okay, so now we have one big arrow here. Okay, and so we've performed this conversion, and so these arrows don't no longer exist, and we put all of that onto a single lump sum on year 17. Okay. All right, so does that make sense to everyone about why we put the arrow on year 17 here? Okay. All right. And so now that we have a single arrow on year 17, here it's really easy. Now we just have to move this lump sum from year 17 back over to year 0. Okay. And to do that, we need a P over F conversion. Okay. All right. And so to this, we're going to add one more conversion factor. Okay. So right in here, we're going to add a P over F conversion factor. Okay. 3%. Okay. And since we're moving this from year 17 down to year 0, the n for this is going to be 17. Okay. And so these two conversion factors here, so we have this P over A factor here, and then this P over F factor here. These are the two conversions that you need to perform in order to take that uniform series that happens at the end back to the present day. Okay. Right, and so you're going to do basically the same thing for the other two cash flows that are not standard. Okay. All right, any questions on this before we jump into annual cash flow analysis?
Professor.
Yeah.
So we take that lump sum and multiply it by the bottom parentheses stuff, right?
Yeah.
And that's how we get the present sum for the whole conversion of this.
Exactly. Yep.
Okay. Thank you.
Yep. Okay. All right. So there's no more questions. Let's go ahead and jump into the lecture notes that I planned for today. Okay. And that is annual cash flow analysis. All right. Okay, and so this is kind of the direct sequel to present worth analysis, okay? Because it's basically almost the exact same idea, okay? It's just that we're going to do it in a slightly different way. Okay? All right, so kind of just and so to just kind of refresh your memory, right? So last week we went over a technique called present worth analysis, okay? And the idea with present worth analysis is that it allowed us to perform economic comparisons between alternatives. Okay? Okay. Right, because whenever we perform present worth analysis, we had a situation where we're trying to decide between two different options, right? A lot of times it's either two pieces of machinery or maybe two different business strategies, okay? And we use present worth analysis to tell us which one was the best one to go for, okay? Which a lot of times either it minimized the cost or it maximized the benefits from this, okay? And so annual cash flow analysis is the exact same idea. And so, just like present worth, we're going to be comparing economic alternatives. Okay. Okay. And so we're still going to be doing this. Okay. But instead of converting everything to a P, now we're just going to be converting everything to a uniform series. Okay. Okay. Right, and so the idea is exactly the same. So basically, you're going to be given a word problem. So the word problem is going to have either two or more different options. Okay, you're going to take all the cash flows for those options and just convert everything to a uniform series. Okay. All right, and so why do we have this? And so it kind of seems redundant, right? And so if we have present worth analysis, this just kind of seems like more busy work that kind of does it, just kind of a different way to accomplish the same thing. Okay. And so the reason, we have this annual cash flow analysis is that it's all due to, interpretation. Okay. And so present worth analysis, I think, is, on the one hand, it's easy to interpret because it puts everything in terms of, money that you have today. Okay. But annual cash flow analysis puts things in terms of, how much that you would have to pay each month over a period of time. Okay. All right, and so this is useful because a lot of times in business or in your personal life, there's often a lot of uniform series payments, right? And so one that I can think of right off the top of my head is repaying a loan. Okay. Right, and so when you're talking about a loan, right, one thing that you can talk about is the present worth of the loan, right? And so if you borrow $10,000 from someone, then the present worth is $10,000, right? And so that's one way that you can think of it. But if you're repaying back the loan, you don't really want to think about it in terms of the present day value because you already know that. What you want to know instead is how much do I have to pay each month in order to repay this loan? Okay. And so in those situations where you would prefer to have the cash flow in a way that that you would want for a given situation, annual cash flow can work for those ones. Okay. All right. And another nice thing about annual cash flow analysis is that it's a lot less picky on the time period for the analysis. Okay. Because if you remember from present worth analysis, we kind of had to bend over backwards and do lots of different things when the ends didn't align, right? And so if you had two parts and one lasted longer than the other one, there's a lot of assumptions and a lot of extra work that we have to do. Okay. Annual cash flow analysis, because of its nature as kind of a recurring payment, it doesn't really care about those things all that much, and so it kind of simplifies your analysis in those cases. Okay. Okay. And so, for those situations where you have, different time periods, annual cash flow will actually be a lot more easy to interpret. Okay. Okay. And so before we start doing some examples, let's define some vocabulary. Okay. Or let's define some terms. Right. And so the first term I want to go over is called equivalent uniform annual cost. Okay. And so since equivalent uniform annual cost is a mouthful, we often shorten it to EUAC. Okay. And so all this is all the costs associated with the project converted to a uniform series. Okay. And so this is just a fancy way of saying, we're going to take all the costs from our project and then perform some cash flow conversions until it's in the A format. Okay. And this takes in all the costs, right? And so that's why it's called the equivalent uniform annual costs. Okay. Okay. Any questions on this? Okay. All right. So that's EUAC. And so next is going to be EUAB, or equivalent uniform annual benefit. right? And so all this is basically all the benefits associated with the project converted to a uniform series. Okay. And so all the benefits that you have, all the revenue, all the salvage value, any other benefits, you're just going to convert them to an A, and then that's going to be your EUA. Okay. All right, and the last one is going to be equivalent uniform annual worth. Okay. Right, and so that's going to be EUAW. Okay. And all this is just going to be the difference between the EUAB and the EUAC. Okay. Okay. And so this is basically everything converted to a uniform series, right? And so, remember in present worth analysis, we took basically the present worth of all the benefits, the present worth of all the costs. We just subtracted the two, and then we ended up with, the whole present worth. And so this is kind of the same thing. Okay. Right. And so computing in terms of, the terms that we just defined is simply just the difference between the EUAB and EUAC. Okay. And so it's basically if you put kind of the net worth of a certain project of all its cash flows, that's called the EUAW. Okay. All right. And so same thing that we had in present worth analysis, when we do annual cash flow analysis, right? What we're looking to do is we're looking to minimize costs, maximize benefits, and maximize EUAW. Okay. Right. And so we're going to look to minimize EUAC. Okay. Okay. Maximize EUAB and EUAW. Okay. All right, and so when we're comparing options, between alternatives, right? And we want to find the one with the minimum costs or the maximum worths or the maximum benefits. Okay. All right. Any questions on this before we jump into an example? Okay, so let's do an example. Let's redo an example from last time, but let's do it with annual cash flow analysis instead of present worth. Okay. All right, and so let's say that we work for an engineering company and they're looking to decide between two different machines. Okay. And so first we have machine A. Okay. And so machine A has an initial cost of $10,000. And then the savings and then it's going to provide your company $3,000 savings each year. Okay, so that's machine A. Machine B has a slightly higher initial cost. So machine B has a $13,500 initial cost. It's also going to provide $3,000 savings each year. Okay. But in addition to that, it's also going to increase in the savings are going to increase each year by $500. Okay. And so option B has a gradient associated with it. Okay. All right. And so for this problem, we're going to assume an interest rate of 7%. Okay. We're going to assume N, our time period is going to be 5. Right. And so from this problem, we're going to use annual cash flow analysis in order to determine which machine the company should buy. Okay. All right, and so just like we did with the examples or the problems that we covered before, is that we're going to take each of the cash flows here, okay, and I've listed them all out kind of in lists like this, and we're going to perform the conversions that we need to for for this analysis, and for this case, instead of converting everything to a present sum, we're going to convert everything to a uniform series. Okay, so any questions on this before we start jumping into the calculations?
Oh, Professor.
Yep. Mm-hmm.
Will N always be in years?
Yeah. So it'll be either years or months. So most of the time it'll be years. But it's there's you usually are not going to mix them, and so a lot of times the problem will tell you this will take place over 7 years or 7 months. And then just whatever that number is, you can use that for N.
Okay, thank you.
Mm-hmm. Okay. All right, and so let's compute the EUAW, or the equivalent uniform annual worth of each of the options. Okay. All right, and so let's start with A. Okay. All right, and so for A, we have an initial cost of $10,000. Okay. Okay. This is a present sum, right? Because this is an initial cost that we're paying out, right away, and so we need to convert this present sum into a uniform series, and so the conversion factor we need for that is A over P. Okay. Okay. You're going to plug in the interest rate and the time period, so we have 7% 5. And then to that, you're going to add the savings each year, right? And so since the $3,000 savings is already in uniform series format, so it's already A, then we don't need to do any converting here, okay? All right, and so if you plug this in and you look up this conversion factor in the compound interest tables, right? Let's see, I think for this one is 0.2439, as you got from the compound interest tables, okay? And so the EUAW for option 1 is going to be $561, okay? All right. And so what this is telling you is that going with option A is equivalent to basically earning $561 each year, okay? Right. And so basically the initial cost of the project is spread out over the 5 years, and that's going to cut into the $3,000 that we're making each year, okay? And so the net amount per year that we're making is $561. Okay. Okay. And so that's the EUAW of option A. Now let's do the EUAW of option B. Okay. All right. And so we're going to take everything in B and then also convert it to a uniform series, right? And so first we have our initial cost. And so our initial cost for B is the $13,500. Okay. And then same as above, we're going to convert this to an A. And so we have A over P, 7% and 5. Okay. Next, we have our $3,000 benefit, which we're getting each year. And so we don't need to convert that at all. Okay. And then finally, we have to convert the the arithmetic gradient. Okay. All right. And so the arithmetic gradient is $500. And so that's the amount that our savings is going to increase every year. Right. And so the conversion factor we need for that is A over G, 7%, and then 5. Okay. All right. And so once again, we have to look these up in the table. Okay. And so this top one here is going to be 0.2439, same as in red. Okay. And then this one down here is going to be 1.865. Right. And so we would perform those calculations, and what we get is $640. Right. And so if we go with option B, that's basically the same thing as earning $640 each year, for over the course of 5 years. Okay. And so since we have a higher number for EUAW for option B, right? Remember, when we're doing this analysis, we want to maximize the EUAW as much as possible. And so this tells us that the best option to go for is going to be option B. Okay. And we use annual cash flow analysis to determine this. Okay. And so this is the exact same result as before, when we did this problem with present worth analysis. It's just that instead this time we did annual cash flow. Okay. And so if you do both analyses, you should get the exact same thing. And so, the conclusion shouldn't change, whether you're using one or the other. It's just a matter of how you want to interpret the results. Okay. Yes. And so the question in the chat is, would it also be right to say option B is more economically efficient? Yes, you can say that too. Yeah. So option B is better because it is more economically efficient. Mm-hmm. Okay. All right, and so you can see, there's not much new to this. It's just that we're converting to a different form instead of present worth. But all the same concepts that we that you used before apply here as well. Okay. Okay. So any questions on this example here? Okay. Okay. And so, for cases like this where the time period is the same, you can choose present worth or annual cash flow. So both of them will work just fine. Okay. Now let's talk about some cases when the time period for analysis is different in between two options. Okay. And so what we saw last week was that, when we're doing present worth analysis, we had to make some adjustments based on the time period. Okay. Okay. And so when the time period for analysis didn't align together, for present worth, we had to basically make some adjustments. Okay. And so what I'll show you in this next example is that when that happens for annual cash flow, you actually don't need to do anything special. And so you can just perform the analysis as usual using the original time period. Okay. Given that the two time periods are they eventually meet up, and that you can assume that that you buy a replacement. Okay. Okay. So any questions on this before we jump into another example? Okay. All right, so let's do another example just to show you, when annual cash flow analysis can really shine above present. Okay. All right, and so I think this is also an example that we had before. I think I just kind of simplified the math a little bit. Okay, and so we have two pumps here, two pumps that are being considered for purchase. Okay. All right, and so these two pumps have the following statistics. And so we have pump A and also pump B. Right, and so both of these pumps have an initial cost, right? And so we have to buy them at some point. They also have a salvage value. And then finally, they also have different useful lives. Okay, and so one pump is going to last longer than the other one. All right, and so for the initial cost for pump A, we have $7,000. Okay. Pump B, the initial cost is going to be $5,000, right? And so pump B is cheaper. Okay. The salvage value for pump A is going to be $1,200. Okay, and the salvage value for pump B is going to be $1,000. Okay. All right, and so in terms of useful life, the pump A is going to last for 12 years, whereas pump B is going to last for 6 years. Okay. All right, and so for this problem, if you remember when we did this with present worth, we had to extend the life of pump B up to 12 years. And then we basically assumed that we purchased a replacement pump at year 6, okay? And so what I'll show you in this problem is that you don't need to do that when you do annual cash flow, right? And so when you have both, pumps where, eventually, their useful lives are going to meet up at the least common multiple, then you don't need to actually, perform any conversions, okay? Okay. And so, to start out with, let's compute the EUAW for each pump, just using the useful lives that we have here. All right, so let's start with pump A. Okay, and so for pump A, we have an initial cost of $7,000. Okay, so that's going to be a minus 7,000. And then to convert this to a uniform series, we need an A over P conversion factor, right? So we need A over P. Okay. Oh, I didn't give you the interest rates. The interest rate here is 7%. Okay. And so we have an interest rate of 7%. And our N here is going to be 12, right? Because the useful life for pump A is 12 years. And so that's why we put 12 there, okay? Right. And then to this, we're going to add the salvage value. And so the salvage value is $1,200. Okay. The conversion factor for this is A over F. 7% and 12, okay? Right, and so if you look up these conversion factors in the compound interest table, what you get is a value of $814. Okay. All right, so now let's go over the EUAW for pump B, okay? And for this, for now, we're going to assume that the N is equal to 6 because that's how long, that's how long we have here, okay? All right, and so we have a minus $5,000 for the initial cost. Okay. And then same as above, we're going to convert this to a uniform series with an A over P, 7%, 12. Okay. right? And then to that, we're going to add the salvage value. And so the salvage value is going to be $1,000. Okay.
Wait, Professor, is it a 6 or is it 12?
Oh, it's 6. Yes, thank you. I'm like falling asleep here. Thanks for catching that. Yeah, so this is also this is 6 years. Yep, because the pump B is only going to last for 6 years. Okay? And so if we perform these calculations here, then this is going to be a minus $909. Okay. Okay. And so from this analysis, you can see that the best option to go with here is going to be pump A. Okay, because this has the minimum cost. Okay. Or it's the least negative. Okay. All right, but we performed this analysis with a different time period. Okay? And so for option A, we use 12 years, and then option B, we use 6 years. Okay. And so, normally we can't do this with present worth, right? So present worth analysis, we said that, we always have to keep the same amount N, the same for every single option. Okay. And so what I'll show you on the next page is that, I'm going to do basically the same thing that we did for, for present worth. And so I'm going to take pump B and I'm going to extend its life to 12 years. Okay. And so then I'm going to buy a replacement at 6 years. Okay. And then we're going to see how that affects our results. Okay. All right. Any questions on this so far? Okay. All right, and so what we're going to do is we're going to recompute. We're going to recompute EUAW for option 2 or option B, okay, with a replacement in year 6. Okay. All right, so just so that you can kind of visualize what's going on, I'm going to draw a cash flow diagram. Okay. All right, and so let's write in the cash flows for the first pump, right? And so in order for this to go for 12 years, we need to purchase a replacement pump in year 6. Okay. So let me write out the cash flows for the first pump first, right? All right, so the first pump we're going to buy today, and so we're going to buy it year 0, and so this can be a minus $5,000. Okay. And then in year 6, when it's done, when it's done doing its thing, we're going to sell it for $1,000. Okay. All right. And so in year 6, in order to get this to year 12, we're going to buy another pump. Okay. And so pump 2 is going to be another $5,000 at the end of year 6. Okay. Right, and then we have the salvage value for the second pump, which is going to be $1,000, which happens at year 12. Okay. Okay. And so, we want to convert this, or we want to compute the EUAW for this cash flow diagram. Okay. All right, and so unfortunately, this is going to involve one non-standard, one standard conversion. Okay, mostly for these guys in the middle, right? Because the uniform series or the EUAW that we want to compute, this has to stretch over the 12 years. Okay? Okay. And so, you know, when you have a lump sum kind of in the middle of your cash flow diagram like this, you need to kind of convert this, more than once. Okay. Because if we took these middle cash flows and we directly converted to an A, okay. And so what we have in the middle there is we have 1,000 minus 5,000, right? And so I'm just going to lump them together into one, you know, just because they happen at the same time. Okay. And so if we try to convert this to an A with A over P, 7%, and 12, okay, right? This wouldn't be correct because what this, what this does is that it basically takes this amount and stretches it over 12 years this way. Okay. Right, because look at the conversion factor that we use, right? The conversion factor that we use was A over P, okay? And so by using this conversion factor right here, what this assumes is that the thing you're converting from, you know, that's kind of the lump sum at the beginning, and then it's going to stretch out to 12 years in the future. And so we can't actually do this, at least not by itself, okay? Okay. In order for this to work, you know, in order for this conversion factor to work, you know, we actually need to move this back to year 0, okay? Okay. Right, because if this lump sum was starting at year 0 and we stretch it out for the 12 years in front of it, that's going to cover, you know, this entire time period right here, okay? And so the second conversion that we need to do is we need to do a P over F, 7%. And 6 years, okay? And so what we have here is a non-standard cash flow because, you know, we have a lump sum that we need to spread out over a longer period of time, okay? But because that lump sum kind of happens in the middle, we have to move it to either the very beginning or you can move it to the very end too. You know, that works as well, okay? Before we can actually stretch it out to, to over that whole period, okay? All right, does that make sense about, you know, why we did 2 conversions here for this middle lump sum? Okay. Oh,
Professor?
Yeah. Mm-hmm.
So is that a mistake? Did you write A over P or should it be P over A?
It should be A over P because what this conversion factor is going to do, and so kind of the order is kind of swapped just because I didn't want to erase it. But the first conversion factor that you should do is this guy, right? Because you're going to take that okay. 1,000 minus 5,000, and then first you're going to shift that back over to the origin, okay? And so that conversion is a P over F, 7% and 6. And then now that you have the cash flows at year 0, you can stretch that out over the 12 years, and that's going to be an A over P. Yeah.
Oh, okay. So it should be P over F, and then after that, then you should multiply by A over P.
Exactly. Yeah. Yeah.
Mm-hmm. Okay. Got it. Thank you.
Okay. And so that's the, that's the middle cash flow. But and thankfully, you know, the other 2 cash flows that we have, you know, they happen at the very ends of the domain. So we don't have to do anything too special for that. Okay. And so next we're going to have a minus 5,000. Minus 5,000, and since that occurs at year 0, the only thing we have to apply for this is A over P, 7% and 12. Okay, and so all we have to do is just stretch that over the 12 years. Okay, and then finally we have the $1,000 salvage value at the end. Okay, and so this is going to be A over F, 7% and then 12. All right, and so we have all these conversion factors, and so you can look these up in the compound interest tables. Okay, so we have this one and this one. These are actually the same. Okay. We have a P over F factor for 12 years. And then we also have this A over F, okay, for the one at the end. And you plug everything in. And what you get is minus $909, okay? Okay. And so if you look at this $909 and then you compare it to what we did before, you know, where we just used 6 years, you'll see that they're exactly the same, right? And so, we went through all this effort here with this kind of non-standard cash flow just to, all kind of for nothing, because, we didn't have to do it, okay? And so basically what this tells you is that, as long as you can assume, as long as you make the assumption that you are going to buy a replacement, eventually, for these parts, you can perform annual cash flow analysis, with different periods without having to kind of forcibly kind of make a longer cash flow diagram like this, okay? Right. And so when you have these situations with different analysis periods, but you can assume that you can buy a replacement and that there's a least common multiple, then annual cash flow analysis saves you a little bit of work, and so it's a little bit faster than than the other way. Okay. Okay. And so I'll write all that down on the next page because it is really important. But I did want to mention it while we're here, and I know people are still writing that down. But are there any questions on this before I kind of write down that point? Okay. All right. And so this example here, highlights a very nice feature for annual cash flow. Okay. Okay. And so in situations where the useful lives of your two alternatives differ, and so just like we did on the previous example, and so in the previous example, we had one alternative that lasted 12 years, another that lasted 6, okay? But, there is a least common multiple of the useful lives. That's not something crazy. Okay. Right. And so in the last problem, 12 was the kind of reasonable least common multiple. Okay. And we make the assumption that we can replace the alternatives with an identical item at the exact same cost and performance. Okay. Right. And so if all these conditions are met, okay, then what we can do is we can compare the annual cash flows for the alternatives based on their service life without having to explicitly factor in the replacements. Okay. Okay. And so that's exactly what we did kind of in the first part of this example. And so in the first part of this example, because we did the analysis on machine B throughout its useful life, which is just 6 years. Okay. without having to actually say that, we're going to buy a replacement, okay? It's already implied just by computing the EUAW, but, we don't actually have to do that, okay? Because as you see, when we actually did it, we ended up with the exact same answer as we did, when we didn't compare, okay? All right, so any questions on this? Does it make sense to everybody? Okay, and so this is really nice. And so for cases where you have a different product life, when that happens pretty often, and so oftentimes different companies make different parts that last a different amount of time. Annual cash flow analysis will save you a bit of time in your analysis. Okay. All right, and so this even works in situations where you're going to be considering equipment that's going to be used for an indefinite amount of time. Okay. Okay, because a lot of times, you're going to be making purchases for your engineering company, and you're going to be purchasing this machine, and you're going to assume that you're going to use it forever, right? And so you're going to be purchasing a pump, or maybe you're purchasing a vehicle, right? So maybe you're not using that specific vehicle, but you need to make deliveries, at least until your company goes kaput, right? And so you can assume that you're going to be using that vehicle, for the rest of days, okay? And so you can use annual cash flow analysis to simplify your analysis as long as you can make this assumption right here, right? And so as long as you can assume that you can buy an adequate replacement, for relatively the same cost with the same performance, then you can use the annual cash flow analysis to make your analysis a little bit easier. Okay. Okay. Any questions on this?
So if we get the EUAW for something, would we be able to translate that to like present worth, since I'd say uniform series?
Oh yeah, definitely. So actually, the two are convertible exactly like that. And so if you compute the EUAW for something, then if you take that EUAW and then just perform a P over A conversion, then you can compute a present worth from that as well. Yeah, and so that's one way that you can link the two analyses. Yeah, and so probably you're wondering, is this one way that we can get around, that one thing for present worth where, when we do have to perform, replacements that we have to factor in like this, you can. And so that should actually work. And so actually, if you take these results here and then you convert that to a present sum, I think you should get the same results from what you did in the previous notes. Yeah. Mm-hmm. Okay. All right, so really quickly, actually, we're just about out of time. So I'll save the next example for next time, okay? All right, and so I have 1 minute left, and so, I'll stick around for any more questions that you guys have on the homeworks or whatever, but, but that's all I want to get to today. So, thank you guys for tuning in today. I hope you guys enjoy the rest of your afternoon, and I'll see you guys on Thursday.
Thank you, Professor.
Yep. Mm-hmm. All right, Nick, you have a question? Yeah, sure. So what's your question, Nick? Yeah. For homework 3B, let me go back to that one. Yeah, so there's multiple ways you can do, like whenever you have kind of a non-standard conversion, there's kind of multiple ways that you can do it. So you're talking about this this part right here, right? Yeah, and so another way you can do this, instead of doing a P over A calculation here, if you instead you do an F over A, right? Right, and so instead if you do an F over A and then you move this, instead of having a single lump sum here, this is going to give you a single lump sum on year 21, okay? And then from here, you can then perform a P over F calculation to to take it from year 21 back to year 0. Okay. But instead of being 17 right here, you can do 21. Right. And that'll give you the exact same thing. Yeah. Yep. Yeah. So there's multiple different paths that you can do for these. And so, there's lots of different ways you can skin the cat.
Professor.
Yep. Mm-hmm.
So with this new annual flow that we just learned, the EUs, are these more convenient to use if there are problems with useful lives, I guess? Is this what we're getting out of this?
Right. And so if the useful lives are different, because remember, you're only going to be using this analysis when you're comparing, 2 or more different alternatives.
Oh, right. Yeah.
Because you want to see which one's the best, right? And so when their useful lives are different, then annual cash flow is going to be a little bit more convenient because you don't have to manually extend the cash flow diagram.
Oh, okay. I see.
Yeah.
All right. And it's easier for present worth if everything is just the same useful life then.
Exactly. Yeah.
All right. Thank you.
Yep. Mm-hmm. Thanks. Have a good day.